Okay, we're going to pick up where we left off on the slides and talk about Docker Compose. Today I'm going to finish up the slides from Wednesday, and then we're going to go into some examples. I'm going to show you some code that uses Docker Compose, an app that uses Docker Compose, and explore how it works and show you in the terminal how to use Docker Compose, because this is a brand new concept. So, are summer classes remote this year? I'm not sure. Oh yeah, Bubber Ducky says yes. I didn't have to read that one. So Docker Compose is solving this situation that we have. So when we're running a database, our database runs as a separate application. It's running its own TCP socket server. It's listening on a specific port, and it's waiting for our app to connect to it. So we have a completely separate process, 100% independent of the app that we're building. The app is going to be its own thing, and it's going to run its own process, and it's going to be a TCP socket server waiting for clients to connect to it. So we have this issue where we have two separate, very separate pieces of software that we need to run, and they need to communicate with each other. So one way to do this, and the pre-Docker way to do it, is to download and install the database, run it on your system, have that running as a separate process, and then start your app, and your app is going to connect to that database. Or maybe you have your database running on a separate server entirely, and you're connecting to a remote server for your database, making that connection. You'll see that out there in industry as well. You'll have a remote database that you're going to connect to. The Docker way to do this is saying, well, that's kind of a pain. It kind of defeats part of what Docker does. With Docker, we want to hit a few buttons, and our app is up and running. So if our startup process, instead of saying Docker build, Docker run, our startup process is now download MySQL, install MySQL, run it, set up your username and password, and then run your app with Docker. That gets painful. Docker Compose is coming to the rescue and saying, let's just run the database in another container. So we're going to run the database in a container, we're going to run your app in a container, and we're going to let those two containers communicate with each other. That's what Docker Compose is going to get us. We're going to set that up in a docker compose.yaml file, and that's going to have all of the setup to be able to do that. So let's take a look at a Docker Compose file. We'll go through this line by line, and I'll explain everything that's going on in this file. But just a quick overview, we're going to create a list of services using this YAML syntax. If you haven't seen this before, it's very similar to Java's JSON, except the white space does matter. So these Mongo and app are part of services, and then build environment ports are all part of app. Wait host is part of environments. So it's kind of like Python in the way that the white space does matter. So we have two services here. Mongo, our database, that's going to run in one container, and then our app is going to run in a separate container. And then those two containers will be able to communicate with each other. Will the database lose content after each startup? No. So if you destroy the container, you'll lose that data. But Docker, even when the container stops, it will maintain the data. It'll keep an image, not an image of the container, but like a snapshot of that container. It'll save all the data. And then when you restart it, it'll be the same exact database. It'll be the same data that's running. It won't destroy any information on the file system of the container. Now, if you destroy that, and there's some I wanted to make sure I mention at some point, so I'll mention it right here. If you destroy that container, you'll lose your data, because the data isn't stored in the image, it's stored in the container that's created using the image. So we're starting with a fresh MongoDB in this case, Mongo image, creating a container of that image, and then as we use it, our data is stored in that container. So if we destroy the container, we lose our data, unless we use what's called volumes, which will back up your data on your local hard drive. So then if you destroy the container, you can create another container and then use your backed up data to be able to load all your data into that new container. So you can use a volume. I don't do it. I won't show that. But you can back up a certain directory inside the container into a local directory on your machine that's running Docker. When you're dealing with data like this, data that you can't lose, you definitely should be doing that. I'm going to show you an example today with data that isn't that detrimental if I lose it. So That being said, I probably should back that up before today's example, because I will be stopping and starting the container. Maybe I'll do that just real quick at some point. So let's go through this line by line. First, the version number. This is the version of Docker Compose. I don't know, the current version might have incremented since I've set up this example. I don't even know what it is anymore. I've just been using 3.3 because it works. I don't know if the version number has increased. If it has, and you want to use a different version, if they're the latest, greatest features of Docker Compose you want to use, change that. If not, just use 3.3. You know at least that it'll be compliant with the lecture example. That has to be there. If that's not there, things break, because you have to tell Docker Compose what version to use. Services is going to specify which containers are going to be spun up. And there can be as many services as you want. This is where you can have many containers. If you want to do, like, for example, load balancing, and you want to create multiple instances of your app, and then have a load balancer in front of that to distribute across those images, you can do that. You can do that just fine. You probably, that specific use case, probably not the best thing. You should probably just do the handle good concurrency inside your app, but you get the idea. If you had this as a distributed system, you could have multiple instances. You know what? Let's not talk about that right now. So services is going to be a list of containers. Those of you using oh man, I forgot which one it was, React, I believe. But those of you using a front-end framework, I've already seen this a few times in the project. You have three images here. You'll have your database, you'll have your front-end, and you'll have your back-end API. So if that's how you have it set up, you just add another service to the Docker Compose file, and then you have another container running whatever you need it to run. So I have two containers here, Mongo and my app. So my app is going to run my app. This is what we've been seeing so far, and I'll explain each line when we get there. And then Mongo running the database is a separate container. These names are whatever I want to name them. I can change these names to whatever. They don't have to be Mongo and app. They can be my super awesome database and my app that is so much better than any other app. Like, that's what I can name these things. It doesn't matter. As long as you're consistent. Whatever you do name these services, that's going to be their host names when you want them to communicate to each other. So inside these containers, if you want to connect to the other container, like say you're inside your app. Inside your app, in your app code, if you do localhost, which for the most part we've used localhost for a lot of things so far in this course, localhost or 0000. If you use localhost, that's going to connect to this container. It's going to refer to the container that you're currently in, the current container that code is running in. If you want to connect to another container, the host name is going to be the name that you gave that container. So if you have MongoDB installed on your local machine and you want to connect to it, you're going to connect to MongoDB at localhost. When you want to connect to this MongoDB in the other container, instead of localhost, you're going to use Mongo, in my example, or whatever you named that container. Make a separate front end for the... Oh, I was referring to the project code for that. But if you want to make a front end for the bonus, then use something like React. I guess I'd be fine with that. This Mongo container, I'm just pulling from an already existing image. This is the same as a one-line Docker file. So we can use a Docker file to build our database if you have extra things you want to set up. I don't have anything else I want to set up, so I'm just pulling the default Mongo image, version 4.2.5. And this is the same thing as having a one-line Docker file. If I said from Mongo 4.2.5, that would build the same exact container that I'm getting here. I'm just specifying the image. I'm saying use this image. And that's it. So I'm getting just a base vanilla MongoDB container that's pre-built and uploaded to Docker Hub. I'm going to download it and just run that image, run a container based on that image. For my app, I have a few things that I have to specify, and this is pretty much the same information that you're inputting when you build and run your container. So when you build your containers based on your Docker file, you always have that trailing dot when you build the image. That trailing dot is telling Docker which directory the Docker file is in. So this is saying build from the current directory. So whatever directory the Docker Compose.yaml file is in, it's going to look for a Docker file in that directory because we're specifying just dot, which is current directory. So that trailing dot, when you build your Docker containers, those are very important because that's specifying where the Docker file lives for that container. And we have to do the same thing in Docker Compose. We're going to tell it where the Docker file is. If you have a Docker file in a different directory, like say you have multiple Docker files in multiple directories, you could have build ./Mongo directory or whatever. You can have different Docker files in different directories. Just specify the path in the build variable in your Docker Compose file. Environment, this is going to set any environment variables that you need. So I'm setting one environment variable here. If you need any more environment variables, this is how you can set them inside a specific image. Environment, anything that you have here, this is going to be the name of the environment variable and then the value of that environment variable. So I'm setting the environment variable wait hosts to Mongo 27017. This solves a very specific issue that we have. This is my recommended solution for it. If you start up a database, it has to go through a whole startup script, and it's going to take a while to get running. It's going to take a while to run that database. You don't just say database go, and then it's immediately up and running. This usually isn't much of a concern, because usually you're starting your database. That database is sitting in the background just running, waiting for connections. And then somewhere down the road, you start your app, and your app connects to the database, and everything's fine. With Docker Compose, that's not quite the setup we have. With Docker Compose, when we run this file, it's going to start all of our containers simultaneously, or at least concurrently. So the database is going to be started, the app is going to be started, the database is going to go through its startup script, and while it's still going through the startup script, in all likelihood, while it's still going through its startup script, your app is going to get to the point where it's trying to make the database connection. It's going to say, hey, database, I'm trying to connect to you. Connections refused because the database is still starting up. It's not ready for clients. Your app doesn't establish a database connection. There's an error. Your app might crash, or it might crash when you first try to use that connection that hasn't been established. There's no connection there, so you can't send any commands to the database because there's no connection there. So that's bad news. So this is a solution to this from GitHub user UFO Scout. Has a really good solution for this. I like it. If you want to look for another solution, use a different solution, go for it. I like this solution. What we're going to do here, we're going to add a few lines to our Docker file. We're going to add this line, or run this line, to download the latest release. I don't know if it's the latest anymore, but download a release of their wait program. I'm going to change the modifications to make sure we can run it. And then in my command, instead of just running the app, I'm going to run the wait command. I'm going to run that program. And then after that ends, I'm going to run my program. What the wait program is going to do is it's going to read the wait host variable. And whatever is listed under wait host, it's going to make a TCP connection to this host. So it's going to make a TCP connection to Mongo, which is this container, on port 27017. And it's going to attempt to make a TCP connection. It's going to start that three-way handshake, that three-way TCP handshake. If it fails, it's going to wait and then try again. If that fails, it's going to wait, then try again. It's going to keep trying until a connection is established. So as soon as this Mongo container is accepting TCP connections on 27017, then the wait command is going to say, okay, I've established a three-way handshake. I've confirmed that Mongo 27017 is accepting TCP connections. And then it's going to exit. And once it exits, my command is going to go to the next line, which is running my app. Oops, my mouse is on the wrong screen. Which is running the app. So once this ends, we're going to run the app after that. So now when the app runs, when our app starts, we're guaranteed that Mongo is accepting connections on 27017. So I like this solution. It's nice and clean and effective. Very effective. It's making sure that this is accepting TCP connections. There's not a whole lot that can go wrong there. Yeah, the wait host doesn't do anything without the command, without downloading this script and running it. Wait host doesn't do anything. Wait host only is read by this specific program. This program, inside it says, read the environment variable wait hosts and then do something with it. Wait host alone doesn't do anything. But if you're able to make your program work, then yeah, it's whatever. If you're able to make it work without this, go for it. It depends on what you're using. Like for your project, if you're using a framework, the framework might do the same thing effectively. If the connection is refused, it'll have some timeout and then try again and reestablish the connection. If you don't have code to reestablish a broken connection, then you have to use something else, which I like this solution. Make sure my database is running before. As long as you have that error tolerance somewhere, you'll get away with it. For your homework, when you're building everything from scratch, like Pockets, is that on your homework or on the project? Like on the project, I'm not surprised if you get away without using this. On your homework, I would be a little more surprised. I'd be interested to see what's happening. Because on your homework, you shouldn't get away without using something to solve this problem. Oh, and I already read all that. Yeah, and shout out to UFO Scout. I never met them. I don't know who they are, but they have a really nice solution here, and they made it freely available with the Apache license. So shout outs to them. And then ports. This is going to specify which local port you're going to map to which internal port. This is the same as your -- publish. You're doing the same thing here, but you're doing it in the Docker Compose file instead of in the command line when you call that. On the homework, yeah, I'll be interested in seeing that. The dog's back there eating something. So this file is this has all the information we need to run both containers. You can C# and where C# has that error tolerance in it. Docker file generated by Visual Studio, or if the Docker file has some. Use the Docker file generated by Visual Studio. Is that even allowed? Did I say that's allowed? I feel like that came up at some point. I thought that came up in a TA meeting. I thought we said that wasn't allowed. Because at first I was like, yeah, whatever. But then I saw one of the Docker files, and it's really complex. If you understand everything that's going on, I'm okay with it. But there's a lot going on in that Docker file, which might handle this situation that we're talking about. With that. So whenever you connect to your database, you're not using localhost. If you've used localhost in your development, get rid of that. We're done with that. When you connect to the database, you're using the service name to connect to it. So none of these. You're still using these when you're listening for ports. When you're listening on port 8000, you're still using your O's. But when you connect to the database, you got to use the service name to connect to that database. Whenever you're communicating across containers like this, you're using the name that you used in the services in the Docker Compose file. And we're at the end of slides. So let's take a look at an example using this. And by the way, I should have time. I'll be able to show a I just thought of something I gotta do just real quick. I'll show a MySQL container. We should have time to see that, but I want to start with a MongoDB, and I will recommend MongoDB. I'm a little hesitant to say that because it is opinionated, but I'm going to recommend MongoDB just because I find, in my experience, it's easier to get set up and running inside Docker Compose. MySQL, I don't know. I feel like every time I use MySQL with Docker Compose, I run into issues that take me hours to debug. And one, I don't want to put you through that. And two, I don't want to put the TAs and myself through that in office hours. I don't want every student who comes to office hours having a 2-hour-long debug session that I'd want to solve. Let's use MongoDB. If you use MySQL, fine. If you want to use SQL. If you want to use Postgres, some of you are using Postgres. Those of you using Django on the project, Django kind of pushes you towards Postgres. If you want to use that on your project as well, go for it. If you're comfortable with that, but if you're not, and you're like, what's all this database and Docker Compose stuff? Save yourself some time. Use MongoDB. But I will show an example at the end. Man, that doesn't. I want to back up my data before I start messing with this, but my console doesn't show me the raw data. Okay, there we go. Got it. Backed up with a good old cut and paste. So here's the Docker file. I believe it's very similar. I think that version of Mongo is higher. I think I upped the version number. And the port's different. I'm just using different ports for this particular app. Everything else is the same that we saw in lecture. And when I connect to that database, and then my Docker file should be very similar to what we've seen, except this is a Node example instead of a Python example. And if we go to app, right there, and I'm looking for a directory. It's at the top level. If we go to app, when I connect to the database, this is where if you were running a local database, you would do localhost 27017. Here I'm using the container that was built through Docker Compose, so I'm going to use Mongo. That's my container name. So that's what I do when I connect to the database, and I want to start interacting with it. So I'm going to get a connection to the database. I'm going to use, by the way, I haven't talked about what to do with the database a little bit. Maybe I should talk about that now. Probably be a good thing. With MongoDB, I pretty much said go look at the docs, which I'm going to stand by that. But since we're in the code, let me look at a little bit. I'm getting the database connection, and then in the routes that I have, we're going to get that database connection. I'm going to get a specific collection from that database. Here I'm getting the music ratings collection. And for this, where I'm returning all the songs, I'm going to find every song in that collection and just return them in random order for my specific application here. When we want to add data to a MongoDB database, and by the way, this is a song rating app. You can go to music.cc-software.com. Let me get that in chat. If you want to play around with this is what we're using for the current 116 homework. I'm getting data from the students so we can start rating songs, sorting them based on their Bayesian average rating. We're doing all kinds of fun stuff. If you want to know about it, we can talk after class. So when a new song is added, I'm going to do a whole bunch of error checking and data validation. And then when we're ready to talk to the database, I'm going to get my collection, which is music ratings here. I'm going to get that collection and call insert and give this a JSON-like object. In this case, it's a JavaScript object. And I'm going to shove that in my database. And now this record is stored in that database. I have a string title, a string artist, an array of ints for ratings, an array of ints for energy ratings, and then a string for YouTube ID. So a JSON formatted object or document in MongoDB speak, and I'm going to add that to the database with insert. Then when another user comes along and wants to rate one of those songs, I'm still going to use man, why am I not seeing it? Music ratings, collection. Let me highlight them. Collection, here we go. When I want to add a rating, I'm going to update all records that match a particular query. So I'm going to update every document containing the YouTube ID of this particular YouTube ID for this song that's being added, which there shouldn't be duplicates because I'm doing a check right here. I'm finding every song with that YouTube ID, and if it doesn't exist, I'm going to add that. Actually, I'm just going to say you can't rate a song that's not in the database, but I'm doing checks. Actually, I missed it up in the other one. I'm doing a check to make sure if that YouTube ID exists, you can't add that song again. So there should be only one unique song with that YouTube ID. If I coded everything right, I'm going to get that song with the YouTube ID and push, which is going to add to a data structure. I'm going to push these values to the ends of the arrays of ratings and energy rating. So this is how we can update a record. In this case, I'm pushing new values to a data structure. You could also use update, which replaces the value entirely. And since I mentioned it, I should check. Should show you this. When somebody's adding a song, I'm going to search. Give me every song with this YouTube ID. And if there's more than one song that's been returned, or more than 0 songs, I'm going to say that song already exists, and I'm not going to add it into the database again. So if somebody tries to add the Rick Ashley 100 times into this damn thing with different titles and flood the database, it's not allowed. You're at the very least going to have to find different versions of the video for each time you want to spam it. Could have sworn it was from 115. Maybe at some point. I don't think we ever did MongoDB in 116 or 115. I could be misremembering though. Yeah, the number of indentations, closing parentheses, and braces hurt my eyes. And yeah, I didn't have to code it like this. This is what we call callback hell. This is what it looks like. I have callback after callback after callback, and then a few ifs, a few conditionals for my data validation. This is not the cleanest way to code things. I don't know. I've lived in callback hell enough times that this doesn't even bother me anymore. But yeah, I remember the first time seeing it. Callback hell kind of sucks. You got all them nested functions for callbacks. I could use promises and flatten this out a little bit. It'd be easy enough to do. I just, I don't know. I'm comfortable enough with callbacks that it doesn't bother me. And the top level callback. Callback hell. Everybody talks about callback hell. This is what they mean. That's it right there. And then the app is here. Enter your UBIT. Well, I'm not going to enter a song, but because I'm not going to go through that. But we have a whole bunch of songs. You can go through and rate them if you'd like. But the next thing I want to show is not that. Is this actual oh my goodness. Okay, change your password if you haven't changed your password. I just sent that email to everybody who hasn't gotten a reminder yet last night. Change your damn passwords, please. I assume anyone who's hearing me say that before Sunday has already changed it, so I'm not going to harp on it. But change your password. And I believe there it is. I don't have my SSH tokens on this. Yeah, that's right. I don't know my password. Oh shit. How did I log in before? I've logged into this machine on this device before. I feel like I did this. I feel like I did the same mistake last time. Does it seem familiar, or are you all feeling like I just did that mistake? I was in the wrong terminal. Can I rant about Windows? Let's get the Windows rant out of the way. Why are there frickin' 5 terminals? Why do I have all these? I shouldn't need all these. I just want one that does everything I need it to do. One of these is my fault. I shouldn't have 2 Ubuntus. That was my mistake I just made too. But PowerShell, command prompt, and an actual Ubuntu, an actual Linux, Unix style command line. Windows, come on. And at least the difference between PowerShell and command line. Why are there 2 of them in Windows? Okay, end Windows rant for the day. We met our quota. We met our requirement. So I'm gonna go to this app, this music rating app, and this is set up with Docker Compose. So great, we have Docker Compose. Everything's set up. Now what? How do I run my app? And luckily, that's the easiest answer. And I just realized I don't have this in the slides. I should have in the slides. But it's so easy as long as you know what things to type. First, I'm going to stop the app. I'm going to do Docker Compose down. Just to get in a state where the app isn't running. This is the state that you'll usually be in before you started. Let me resize this, so I don't have to keep switching between them. And this should be down. Bad gateway, nothing's running. If we want to start the container, up. And that's it. All the other information that you had in building the image and what you would type to do that, and running the container based on that image, all that information is in the Docker Compose file. So you don't have to type that every time you run it. Yeah, the port, that's in the Docker Compose file. We don't have to do -- publish and then the port numbers. We don't have to do any of that. We just run the thing. This app's running now, and we can confirm that our data is still there, which it is not. Oh my goodness. Oh my goodness. I think I actually did wipe my database. Well, good thing I did back it up, but that's going to be fun to fix. I am glad I backed it up though. So let's end this. Apparently Docker down, Docker Compose down. I learned something today. TIL. We'll wipe your database. That's why we back things up. Do we need to use pip freeze within our Docker file? I don't even know what pip freeze does. Oh, yeah, because I changed my key bindings. And if you make a change to the code, so Docker Compose up will not rebuild your containers. If you do Docker Compose up, it's just going to rerun your containers. So you can either do Docker Compose, if you make a change to the code, whenever you make a change to the code, you either want to do Docker Compose build and then Docker Compose up, or if you want to do it in one shot, Docker Compose, I'll get there, up, dash build. I believe it's dash build. Now it's going to build the container, and so you can see it running through my Docker file and rebuilding. When we just did Docker Compose up, it didn't rebuild the container. It just went right into starting the apps, to running the commands for each container. When I do dash build, it's going to rerun my Docker file. It's going to rebuild my image, which it didn't have to do anything here. Everything was cached, and there were no changes detected because I didn't change anything. And then run the app. Which we want to go one step farther on this. Oops. So we want to go one step farther and add a -D as well. That's going to run you in detach mode like you've seen before. So if I'm not interested in seeing the logs and I just want to run this in the background, like this app, I just want it running. I want that running forever in the background. I'm going to do it that way. And then another thing I want to show, since we're in here, that I plan to show is something I had never showed before, is entering a Docker container. So if you do Docker PS, you can see all the containers that are running. And I can see my 2 music rating containers, my MongoDB and my app, both running. And say I have a reason where I want to enter this container, which I absolutely have a reason now because I want to get all my data back in there. I'm going to grab this ID and I'm going to type this very specific command, docker exec-it container name bin bash. /bin bash. If you don't memorize that, I only memorized that because I was going into containers yesterday, so it's fresh in my memory. If you don't remember it, I always Google Docker enter container, or DuckDuckGo it. Docker enter container. This should be the first hit. Docker exec it, and they just use bash. If you have that linked in your container, it's fine. Bin bash, I know that's going to be there. So we can get in this container. We can run all our command line, our Unix commands. We can see all of our code here. If I check the present working directory, I should see /root because that's what we set the home directory to. So when I log in, I'm going to be in /root. That's the home directory. And I see all the code for my app sitting here. And I can take a look at all this code, the Docker Compose file, whatever I want to look at. Exits that container because I don't really want to be in that one, but I do want to be in the MongoDB container. So let's enter the MongoDB container, and I can see some stuff here. The present working directory will be different, just the root directory. I'm in the root directory of a machine, and I know that Mongo is running on this machine. So I'm going to do Mongo, which is going to give me a CLI for the Mongo database. And I can do like show databases because I forget what I named them. Does this not? Oh, I gotta do something quick. Cause yeah, everything was wiped. And I'll just add a fake song for now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Test. Artist. And we really like this song. So we'll have this music database. So we're going to use music to get into that database. I believe it's show collections. It's going to show me the collections in this database. And now say I want to look at all of the ratings. I'm going to do db.collectionName music ratings .find, and now I can punch in my commands that I want. And I always like adding a .pretty at the end, and it'll pretty print the information. So I can see the song that I added. Oh, a real song too was added. All right. Why did that? Oh, because I don't have any. I don't have server-side pushes. And we have 2 songs. We can see these 2 songs in our database. And my task is to get all this data back in. It shouldn't be too hard. It should just be I should just be able to do insert YouTube and this will probably break some things, but I can get my song in there. So that's what I'll have to do. I'll have to take all my data here and shove it into the database again. Shouldn't be bad. I'm so glad I backed that up before I did that. That would be a lot of effort from 116 students lost. That's why we back up data. And Docker Compose down will wipe your database. Don't forget that. Don't forget that. Or you'll do some really bad stuff like I just did. Maybe I'll try to get the data back in there. You know what? I do lose some data. Because I didn't back up everything because I didn't think I'd actually be silly enough to break things. But I am going to lose some data there. Let's go. Let's head over to a Sql Docker Compose. So let's see the same thing here. Here I have 3 containers. We can ignore the Nginx one. We'll talk about Nginx after the homework 5 content. But let's see an example of a SQL, MySQL container. And let me catch up with chat. I see ProRobos questions. I got to read these. One hangs on the attaching step. You know what? I'm not sure about that. Oh, nice. Yeah, I didn't know about that. We can enter a container through Docker Compose. That seems a little easier. So will Docker Compose down be removed from... Oh, yeah, good point. Yeah, I'll do that after. Let me finish this up, and then I'll make those changes. So with SQL, with MySQL, there's more stuff that you have to add in. So MySQL, when it starts up, it'll look for these environment variables to set usernames and passwords in your database for database name for the database. You'll need these for, or at least these 2 values at a minimum, to be able to set up a SQL, I keep wanting to say SQLite, a MySQL container. That's going to set your initial passwords. MySQL will not work without having a password set up, at least having the root password set. You have to log into a MySQL account. MongoDB, if you're on the same machine as MongoDB and you have permissions from the file system at the Linux level, at the OS level to access those files, MongoDB is going to let you in. And then MongoDB isn't going to allow remote connections. MySQL has a bit of a different design philosophy. It says we're going to allow connections from anywhere as long as you have the password by default. You can change the settings in either one and have them behave any way you want, but the defaults are what we're talking about. MySQL defaults to you have to have a user account. MongoDB defaults to let's not mess with accounts unless you want to set up accounts. So with MySQL, you do have to set up your passwords through environment variables, and then you can also set those values. You can do this any way you want. I recommend doing it this way. Set those same username and passwords as environment variables in your container, and then in your app, read these environment variables to be able to get the right values. So those, by having environment variables and having them all in one spot here, 1, never check in your passwords to version control, and then 2, when you are ready to deploy, you clone this repo and you're ready to run, you go in just one file, go in your Docker Compose file, change these passwords to whatever you want them to be, change the database name if you want to, change all these to whatever you want them to be, and then build your containers with those values. One thing to note, these values, these environment variables, are only read by SQL the first time that it runs. So if you're building the container with certain variables and then you change your Docker Compose file and expect your variables to change in MySQL, Don't expect that. It will not change. It won't change until you destroy that container and rebuild a brand new container, because MySQL is only going to check these environment variables the first time that it's starting up. It will not recheck them to see if the password has changed. So that's one of those multi-hour debug sessions that I had. I kept changing. I changed the password early on, and then I could never establish a connection. Finally realized that it was never, like, I had to manually destroy the container. It wasn't resetting that.